So, good morning, dear students. So, I'm just continuing the last class. So, last class we have discussed NMR, isn't it? So, NMR is nothing but every nucleus is having its own spin, and it is also having the states, its spin states. So, the number of spin states is generally depends on the quantum number that we have discussed. So the nuclei which is having the spins which will not differentiate its transition states unless it is in the presence of external magnetic field. As nuclei is having the spins, it just behaves like a small bar magnet. That means whenever we keep the nuclei in the presence of external magnetic field, then it will differentiate its spin states so that at that time when you apply the radio frequency region, the nuclei will absorb that radio frequency region and it will excites from one spin state to another spin state. For example, we have seen proton, that means proton, that is H1, so that is having the odd atomic mass, isn't it? So odd atomic number, that is nothing but it is having the only one proton, it doesn't have any neutrons. So whenever the proton generally it is having the two spin states, so it will not differentiate its spin states in the absence of external magnetic field. But if you apply the external magnetic field, it differentiates its two spin states, and that will be spin states. And when you apply radio frequency rays, it will absorb the rays and it will exit from one state to another state. And the two states are nothing but one is parallel orientation and second one is anti-parallel. So parallel is nothing but, as we have said, nucleus itself will act like a small bar magnet, so that in the case of parallel, the bar magnet will align, the bar magnetic field aligned to that of the external magnetic field, and which is a very stable state which is of very low energy. But what is the other state? That is anti-parallel, which is a unstable state with more amount of energy, and it will aligns opposite to the external magnetic field. So whenever we apply energy, our radio frequency region, which is in the form of energy, so that will exit from one state to, that is parallel to anti-parallel. So as we said, the anti-parallel is a more high energy state, but it is unstable. So what will happen? It will releases that energy and come back to original state. So why we are studying all these? So what is the need for a molecule to absorb, and why we are studying all these process? Because in the case of spectroscopy, so whenever a molecule absorbs NMR, or whenever a molecule absorbs radio frequency or any region of the EMR, so it causes some changes in the molecule. So that changes will be shown in the form of a spectrum. So that changes will be mainly due to the some maybe presence of some functional groups, or maybe due to the presence of some hydrogen bonds, maybe due to the presence of some different types of protons, etc. So for example, I can say, so last class we have seen the spectroscopy, that is in a mass spectroscopy. So in the mass spectroscopy also you will get a spectrum. So what is a spectrum? Spectrum is nothing but that is the graph which is given by the instrument. So so all this process will takes place within the instrument itself. We can't know so how the radio frequency region, how the radio frequency rays are absorbed by the molecule, and how it is undergoing changes, and how it is exited from one state to another state. We don't know all these things. Just we are just simply putting the sample in the instrument, and all this process will be takes place in the instrument. So why we are doing all this? Because when the molecule excited and it will comes back to the original state, in that process it will releases some amount of energy. So that amount of energy will be taken by the various components of the NMR, and that will be analyzed, and that will be given in the form of a spectrum. Spectrum is nothing but the graph which is given by the instrument. So the graph which is given by the spectra is called a instrument is called a spectrum. So in the case of UV visible, that is UV visible spectra, or in the case of mass, that is mass spectrum, or in the case of IR spectrum. So IR spectra. So what is the main role of IR spectra? So IR is mainly used to find out the various types of functional groups which are present in a molecule. That means whenever you see the IR spectrum of a first particular molecule, you will came to know. So what are the different functional groups that is present in a molecule? For example, you can say this molecule is having the alcohol, this molecule is having the carboxylic acid, or this molecule is having some other functional group. So in the same way, so why we are seeing the NMR? So this NMR spectra will give the some information. So what is meant by interpretation? So interpretation is nothing but knowing some amount, some information about a molecule with the help of a graph, that is spectra is called as the interpreting. That means you are extracting some amount, some information from a particular NMR graph or NMR spectra. So that is called as the interpreting. So coming to the main, so this NMR, so I already told NMR will not be possible for all the molecules. NMR is possible for the molecules which are having the odd atomic mass. That means it should not have the same proton and same neutron. It should have the some difference between the protons and the neutrons. That means they should be odd or either one should be odd. Is it clear? So if the both the protons and the neutrons are even, then it will not have any spin states. That means it will not absorb any radio frequency, and we cannot get the NMR spectrum from that molecule. So by seeing the NMR spectra, we can say that we can say, so and generally NMR is of several types, like it is proton NMR. So proton NMR will give say information about, so how many number of protons are there and what type of protons are there, whether it is an aromatic proton, whether it is a whether the hydrogen is attached with the oxygen, or whether the hydrogen is freely available, or whether the hydrogen is present besides any electronegative molecule. So all these types of, so how many types of protons are present, so all these types of information we can get it from the NMR spectra. So I think you people got a idea so why we are studying this NMR spectra, isn't it? So next we are going to see the interpreting proton NMR spectra. So interpreting is nothing but what is the information that you will get from the NMR spectra. So these are the information that we can get it from the NMR spectra. So each different, so in the case of NMR spectra, we will get some different types of peaks. So each peak will tells different type of hydrogens that gives a peak. So we will interpret the graph itself. Okay. Then you will, then you people will easily understand what is a interpretation, what is NMR spectra. Okay. And the chemical shift. So chemical shift is the another terminology that is generally used in the NMR spectroscopy. So that we will also see in a brief. So chemical shift, what is the role of chemical shift? That will gives the clue. So what type of hydrogen is generating the peak? Whether it is alkene hydrogen, benzene hydrogen, or aldehyde hydrogen. And the integration. What is meant by integral? Integral is nothing but area of the peak. That is, the peak area will gives the number of relative number of each type of hydrogen. And we also see the spin splitting. So spin splitting will give the information about the adjacent hydrogen. So adjacent hydrogen అంటే చూడండి మనకి చాలా మంది ఉంటారు, వాళ్ళ ఇన్ఫర్మేషన్ కన్నా పక్క వాళ్ళ ఇన్ఫర్మేషన్ ఎక్కువ ఇస్తారు. సో దట్ మీన్స్ నథింగ్ బట్ spin splitting. And the coupling constant is also will gives the information about the coupling constant will also gives the information about the arrangement of the hydrogens. Okay. Next, so this is coming to the chemical shift. So chemical shift. So what is meant by resonance? So resonance, we have seen that resonance is nothing but, so we have seen the Larmor equation. That means that is every molecule is having its positional frequency, isn't it? What is meant by positional frequency? The frequency are the number of revolutions that was made by the given spin at a in a per second. So I have already told that every nuclei itself is having some spin and it will spins on its axis. That means rotational frequency is nothing but number of revolutions made by that nuclei per second. When the positional frequency of nuclei is equal to the frequency of the radio waves, radio frequency region, then only the molecule absorbs the radiation. So that process is called as the resonance. So theoretically, we will study more factors, but practically it may not be possible in all the cases. I think you people may know in the project session, isn't it? So madam told like that, but it is coming like this. What is this? So you people will know, came to know. So how and maybe you might know that because you are doing the practical daily, because theory is very different from the practical, because there are number of factors will influence the practical. So the utility of NMR is that all protons do not show resonance at the same frequency. Why all the protons? So I already told that NMR is mainly used to know what are the different types of protons which are present in a given given region, isn't it? So that means, so why so utility of NMR is to know different type of protons. So that's why the protons, so all type of proton will not show the same resonance at the same frequency. Why? Because each proton may be surrounded by the different type of molecules, isn't it? So hydrogen may be surrounded with the nitrogen in the case of amines, or the hydrogen may be surrounded with the oxygen in the case of hydroxyl groups, isn't it? Because each proton will have the different electronic environment from one another. And the position of signal, will helps to know. So whether it is aromatic, aliphatic. So you people know aliphatic is nothing but simple chains, isn't it? Alkenes. Aromatic is nothing but when it is linked with the benzene, styrenic, vinylinic. So all these, so whether it is present besides the electron withdrawing or electron releasing, or it will absorb at the different field strength. So the relative energy of resonance of particular nucleus is mainly due to the results from the local environment. That is called as the chemical shift. So NMR spectra shows the applied field strength increasing from left to right. So generally spectrum will be, we will going to see. So but in the case of NMR spectra, in the x-axis, that is in the x-axis, it will be shown like a increasing magnetic field. That means from left to right, the magnetic field will be starts. That means the left part is the downfield and the right part is the upfield. Downfield is nothing but with the less strength, that is low strength, and the upfield is nothing but the with the high strength. So the nuclear will, what will happen? The nuclear will be absorbed on the high field side, are strongly shielded. So in this case, you came to know the different types of terms. I will explain in a detail. Don't worry. So so let's consider. So this is a proton NMR. So this is the peak that we get in the NMR spectrum, isn't it? And this is a proton in a organic molecule. And so what will happen? This is a increasing magnetic field. I already told that the nucleus should be applied with the external magnetic field. So how you will apply? From start low to high. So this is a increasing magnetic field. And so that means this is a down field and this is high field. Okay. Next. So this is a low field and this is high field. Okay, I will explain once again what is a downfield and what is a. So you people have heard the term that is shielded and the dishielded, isn't it? Deshielded. So shielded, what is meant by shielded? So shielded simply terms like, suppose for example, hydrogen is bonded with the several types of functional groups, isn't it? If the hydrogen is bonded with any electron donating group, so any electron, if for example, we can say electron donating groups like OH and O2. So if it is surrounded by any electron donating groups, so that the hydrogen will takes that electrons and it will be more protected. That means it is more shielded, isn't it? So more shielded. For example, ఇప్పుడు మనం తీసుకుందాం అండి, జనరల్గా తీసుకుందాం. సో జనరల్గా తీసుకుంటే మనకి ఎక్కువ సెక్యూరిటీ ఉందనుకుందాం, ఓకేనా? ఎక్కువ సెక్యూరిటీ మనకి ఇప్పుడు కాలేజీలో తీసుకుందాం. మన కాలేజీలో బాగా సెక్యూరిటీ ఉంది, అవునా కదా? ఉంది. ఎందుకంటే అండర్ స్ట్రిక్ట్ రెగ్యులేషన్స్, ఇజంట్ ఇట్? సో అంటే మనకి పాజిటివ్గా అంటే ఏంటి? మేబీ మీ స్టూడెంట్స్ డిఫరెంట్ అయి ఉండొచ్చు, కానీ మనకి స్ట్రిక్ట్ సెక్యూరిటీ ఉంది కాబట్టి ఏంటంటే ఎవరైనా సరే వచ్చి మనల్ని అటాక్ చేయడానికి అంత ఈజీ కాదు, ఇజంట్ ఇట్? So outside the gate, that is another matter. But what will happen? So any can enter the no one can enter the college. Why? Because we are strictly shielded. That means we are strictly shielded, and the watchmen that are standing there, they are giving the protection to us. That means no one can enter the college without any id proof, isn't it? So that means the ir, so in the same case with the proton, so what will happen? So proton is shielded with the electron giving groups. So electron giving groups, so that the electrons will be surrounded around the hydrogen, and the radio frequency rays initially they may not causes the excitation. So by giving more amount of magnetic field, so the small magnetic field may not causes the transition of, may not differentiates the spin states. So what will happen? You have to give the more strong magnetic field. So if you're giving the strong magnetic field, so if the molecule is more shielded, that means you have to give the more strength of magnetic field. So high strength magnetic field is more required in the case of hydrogens which are surrounded with the electron giving groups. So in the case of, in this case we can see that this is the down shielded, that means the hydrogens are surrounded with the electronegative groups. That means they will itself will takes the electrons from the hydrogen. చూడండి మనం బయటికి నైట్ టైం అలా వెళ్తే ఏమవుతుంది, మన సెక్యూరిటీ ఉండదు, అండ్ there may be a chances of people taking all the things from us, isn't it? So that means we are de-shielded, we are not under the protection, we don't have any security. That means anyone can enter and anyone can take. So in that case what will happen? The radio frequency region, the magnetic field that is applied is very less is sufficient. So that means whenever the hydrogen, whenever the molecule, that is whenever the proton is shielded, it requires more field, that is more strength of magnetic field is required. Whenever it is de-shielded, it requires only less amount of magnetic field strength. So I think you people got the idea, isn't it? So next, so measuring the chemical shift. So chemical shift is, we can say that, so chemical shift generally we will not show, we will not explain, we will not give the result in a single manner. So that means, for example, if you ask any student, so what is your marks? For example, you just passed, okay? You just passed in not in math, in any other subject, okay? So if you are just passed in any subject, okay, then I ask you, so what is your marks in that particular subject? Then you will say, ma'am, I am first in the class. Why? Because rest of all the students are remaining, all my friends are failed in this subject, except I only passed in the subject. That means you want to share, that means you want to show a result comparative to the your friends, isn't it? Or for example I can say that, for example, mm, in any other prospect, for example if any institute, if one is working, for example if you take any software company, so generally what will happens, they will for example you can take a gpat exam. So what will happens in the gpat exam, generally you people will get cut off with respect to top ranker. You will not give the cutoff individually, because so the cutoff will be maintained with respect to result of the first rank student. So that means you are comparatively you are selected. In the same case, the chemical shift will be comparatively expressed, isn't it? So the difference between the strength of magnetic field at which the absorbed nucleus resonates and the field strength of the resonance of a reference. So I think you people got the idea. That means you are showing the chemical shift with reference to any reference molecule, any reference or any standard molecule, isn't it? So in the same case, so in labs also we will find out whether the molecule is correct or not. So if I gave any paracetamol, so suppose I gave some talcum powder and I ask you to find out whether it is a paracetamol or not. Then you have, then what will you do? You have to take the IR spectrum of a original paracetamol substance, isn't it? So original standard paracetamol IR spectrum should be taken, and you have to take the IR spectrum of the powder that I was given to you, isn't it? So then you have to compare. So whenever you are finding whether the compound is correct or not, you will always compare with the standard one, isn't it? So in the case of calibration also, you will compare with the standard only. So that means in this case, the chemical shift can be shown or expressed by comparing with the reference one. So for measuring the chemical shifts of various protons in a molecule, the signal of TMS. So TMS is nothing but tetramethylene sulfate. So is taken as a reference. So in this case, TMS is taken as a standard one. Why? Because it will give a correct signal. So that's why this TMS is taken as a standard compound, and the NMR signal for a particular protons will appear at a different field strength compared to signal from TMS. So the difference in the absorption position of the protons with respect to TMS signal is called as the chemical shift. I think you people got the value. Chemical shift is generally expressed in the case of delta. And what will happen whenever you try to express chemical shift, the chemical shift will be generally expressed only by comparing with the signal of a reference compound, that is a TMS. And what is a chemical shift? The difference in the absorption position of the proton with respect to TMS signal is called as a chemical shift. So you people can understand. Uh, rather measure the exact resonance position of a peak, we can measure whether it is a far away from the TMS or whether it is a close to the TMS. So generally TMS value is at 0. So I already shown in the last graph, isn't it? So this is the graph. So this is a 0 and this is 10. So all these are the values of the chemical shift, but the strength of the magnetic field is keep on increasing. That means this is a low field and this is high field, isn't it? So when the magnetic field is increasing from one to another one, and this is a, what is this thick peak? This is the peak of a reference, that is TMS. So whenever you're expressing the chemical shift, you will express only by comparing with the TMS. So that means when you say this is a low field, that means it is very far away from the standard. And when it is a high field, that means it is very close to the and standard. And moreover, low field, high field is nothing but the strength of the magnetic field is keep on increasing. So this is the, so we will see this is a hydrogen, isn't it? So NMR is, whenever we are thinking about the NMR, just think about the protons that are present in a given structure. So this is the reference compound is nothing but, sorry, I told you wrong. TMS is nothing but tetramethylsilane. So, highly shielded. This is a highly shielded. How can you say that this is highly shielded? Why? Because this proton is in connection with the electronegative compound, that is a carbon and silicon. So what will? Sorry, they will. Um, they will in connection with the low electronegative compound, or they will easily donate the electrons, so that the hydrogen will be highly shielded, and it requires a more amount of more strength of magnetic field to show its resonance. So this is a TMS and this is the molecule. Okay, next. And tetra, why we have selected, sorry, wait. Okay, so this is the one of the exam. So this is the structure of tetramethylsilane and which is highly shielded. That's why it shows at the zero level. Okay, zero is the initial point, and which is can be taken as a reference standard. So that's why it will give say always it will give say uniform peak, and it will not shows any fluctuations, and it is highly shielded compound. That's why it is taken as a reference compound. So this is a tetramethylsilane, and which is used as a internal standard. This IS is nothing but internal standard. So what are the main factors which are mainly why we have taken the TMS as a internal standard? So it is a chemically inert, and it is easily miscible with the large number of solvents, and it is having the total 12 protons, isn't it? So it is having 12 protons. So 3, 3, 3, 3. Okay. And all these are the magnetically equivalent. That means they will not be surrounded by the different molecules. And each proton, so each proton is highly shielded and it gives a strong field, strong peak even in a small quantity, and they are less electronegative when compared with the carbon, and it is highly volatile and we can be easily removed and we can get the sample. Okay, so whenever we are going for the NMR spectra, we have to mix with that internal standard. So what will happen if the internal standard is completely mixed with the sample and we cannot separate, then the sample will get wasted. So but in this case that EMS is volatile, that means we can easily separate the sample from the internal standard. And this is the chemical shift. So the chemical shift formula is nothing but shift in heads. Shift in, what is the shift in heads? That is nothing but difference between the difference in the absorption resonance of the particular molecule from the TMS by frequency, that is the frequency of radio frequency region in megahertz. And generally the chemical shift will be generally expressed in the ppms. Sorry. Mm. Next, the alternate system. So, along with the chemical shift, we have the another alternate system which is used to find out the resonance of a particular compound related to the reference. That is called as the tau. So, the small numerical value of the tau indicates a small downfield, and the while large value indicates the large downfield. So that means tau is equal to, there is a relation between the chemical shift and tau. So tau is equal to 10 minus delta. Okay. So this 10 minus delta will gives the original value of the tau. So in the case of delta, if your delta value is very less, that means it is at a high field. The delta value is more, that means it is a downfield. But in the case of tau, so tau is nothing but low field, and so small numerical value of delta indicates a small downfield, and the larger value will gives the large downfield. So small downfield is nothing but which is at a high field, and the small value of tau represents a low field absorption, and the high value indicates the high field absorption. So high is nothing but this is at a high field, low is nothing but it is at a downfield. Okay. So what is meant by shielding and dishielding? So I already gave the some introduction. That is the rotation of electrons to nearby nucleus generates a field. So I told that whenever the proton is present, proton around the proton, it may have the some amount of electrons, and that electrons causes a field on the protons. So if the magnetic field is if you apply the magnetic field, that magnetic field may oppose the magnetic field, external magnetic field, and then you can say that that is the shielded proton. So when it will oppose, when the electrons around that particular nuclei is more strong, that means the magnetic field around that proton is more stronger than the applied field, then the proton feels more secure, and it is having the more magnetic field, and then you have to apply the more strength of, you have to apply the high strength external magnetic field, isn't it? So if the magnetic field is opposing the magnetic field on the proton is said shielded proton. And if the field is strong, then the applied field, then the proton feels high magnetic field, and such proton is called as the deshielded. So once again I am explaining. So what is meant by shielded and deshielded? So in the case of shielded proton, the proton is highly surrounded by the more number of electrons. That means that electrons will create a field, and that field is more stronger than the external magnetic field, so that proton is a shielded one. So in the case of shielded one, what will you have to need? You need to apply more amount of more strong magnetic field. So in the second case, if the proton is surrounded with the electron withdrawing groups, that means they takes the electrons from the proton itself. So the protons will not be surrounded by any electrons. That means it is deshielded without any protection. So such proton is called as a de-shielded proton. So shielded proton, what will have, what will it do? It will shift the absorption signal from left to right. That means it will shows the signal at the upfield. And in the case of de-shielded proton, so it will shift the absorption spectrum from uh, right side to left side. So electric environment surrounding the protons will tells whether the electric environment surrounding the proton tells us where the proton shows the absorption spectrum. So the electrons around the protons will create the magnetic field that opposes the magnetic field since it reduces the field. So what will happen? For example, this is the electrons. So it will create some field and this is the applied magnetic field, isn't it? So what is the principle in NMR? So the NMR spectrum will be formed from the molecule only when it shows the two different spin states. And the so NMR spectrum is possible only when the molecule absorbs the radio frequency. When does it absorb the radio frequency? When only it shows the two spin states. When it shows the two spin states, only when there is a external magnetic field. So the external magnetic field should be very sufficient so that it will differentiate the two spin states. Okay. సో ఇదేంటంటే స్టోరీలా ఉంది. ఓకేనా? అదెందుకు జరిగిందంటే ఇది ఎందుకు జరిగింది. అసలు ఇంకా సింపుల్ టర్మ్స్లో చెప్పాలంటే మనకి ఏదైనా సరే స్పెక్ట్రమ్ కావాలి అంటే ఇప్పుడు సపోజ్ యూవీ విజిబుల్ స్పెక్ట్రోస్కోపీ అంటే ఏంటి? ఆ మాలిక్యూల్ యూవీ విజిబుల్ లైట్ని అబ్జర్వ్ చేసుకొని ఉండాలి. అలాగే ఐఆర్ స్పెక్ట్రోస్కోపీ అంటే ఏంటి? ఆ మాలిక్యూల్ ఐఆర్ రేడియేషన్ని అబ్జర్వ్ చేసుకొని ఉండాలి. అలాగే ఎన్ఎంఆర్ అంటే ఏంటి? ఆ మాలిక్యూల్ ఆ రేడియో ఫ్రీక్వెన్సీ రీజియన్ని అబ్జర్వ్ చేసుకోవాలి. సో ఇక్కడ మాలిక్యూల్ ఏమవుతుంది? రేడియో ఫ్రీక్వెన్సీ రీజియన్ని అబ్జర్వ్ చేసుకోవాలంటే ఏంటి? దానికి ఉన్న టూ స్పిన్ స్టేట్స్ కూడా డిఫరెన్షియేట్ అయి ఉండాలి. అంటే ఒకటి ప్యారలల్ కింద యాంటీ ప్యారలల్. కానీ అలా జనరల్గా ప్రతి మాలిక్యూల్ అలా డిఫరెన్షియేట్ చేసుకోలేదు. సో అలా మనం డిఫరెన్షియేట్ చేయడానికి ఏం చేయాలి? బయట నుంచి మనం ఎక్స్టర్నల్ మ్యాగ్నెటిక్ ఫీల్డ్ని అప్లై చేయాలి. సో బయట నుంచి ఎక్స్టర్నల్ మ్యాగ్నెటిక్ ఫీల్డ్ ఎందుకు అప్లై చేస్తున్నాము? దాట్ మ్యాగ్నెటిక్ ఫీల్డ్ షుడ్ బి మోర్ సఫిషియంట్ సో దట్ ఇట్ విల్ డిఫరెన్షియేట్స్ ద టూ స్పిన్ స్టేట్స్. సో ఈ మ్యాగ్నెటిక్ ఫీల్డ్ స్ట్రెంత్ ఎంత ప్రొవైడ్ చేయాలి, మనం ఎంత ప్రొడ్యూస్ చేయాలనేది దేని మీద డిపెండ్ అయి ఉంటుందంటే ఎలక్ట్రికల్ ఎన్విరాన్మెంట్ అరౌండ్ దట్ ప్రోటాన్. అంటే ఆల్ టైప్స్ ఆఫ్ ప్రోటాన్స్కి, అంటే డిఫరెంట్ టైప్స్ ఆఫ్ ప్రోటాన్స్కి నువ్వు సేమ్ మ్యాగ్నెటిక్ ఫీల్డ్ ఇస్తానంటే కుదరదు. So you have to vary the magnetic field so that the proton which are shielded will be differentiates at a higher strength of magnetic field, and the protons which are de-shielded they will obviously will be differentiates at a low speed. Is it okay? Is it okay? So I think you people got the idea. So whenever, so what is the need? So if the proton is more shielded, you have to provide large amount of magnetic field so that it will differentiate the spin state. Whenever it differentiates the spin states, then only it will absorb the NMR, that is radio frequency region. That is very important for our molecule. In order to get the NMR spectrum, you have to do all these process, and all these process will be takes place within the instrument itself. Okay. Sorry, this is some sound from outside. And the shielded protons, so the magnetic field strength can be increased from a shielded proton if you look at the same frequency. So here you can say, so this is the naked proton. So generally the naked proton will be absorbed generally 60 megahertz, and the shielded proton maybe it feels very less, so this may be very less. So you have to apply more amount of magnetic field. Is it clear? So this is a only naked proton, that means it doesn't have any functional groups attached with this proton. So this will generally absorb say 60 megahertz. But if the proton is highly shielded, this magnetic field, that is this magnetic field, so generally magnetic field strength can be shown with the help of gas. So the units are gas. So this 14.092 is not sufficient for a shielded proton. That means it will not absorb any radiation. So in order to absorb the radiation, you have to apply more stronger field so that it will be easily pass into that that electron shield. Okay. And the protons are shielded by the electrons that surround them. In an applied magnetic field, the valence electrons of the protons are caused to circulate. That circulation is called as so generally every molecule is having its own electrons. So the electrons will surround the electrons will rotate around the proton, so that will causes some current that is called as a diamagnetic current, and that magnetic may be opposes the external magnetic field. So that shielding is called as a diamagnetic shielding or diamagnetic anisotropy. The counter field that shields a nucleus diminishes the net applied magnetic field that the nucleus experiences. So this is all nothing but so whatever I have explained that was written in the matter. That means if the molecule is highly shielded, you have to provide the large amount of energy. Why? Because the shielded protons itself will produce some amount of magnetic field. In order to differentiate the two spin states, you have to provide the magnetic field externally in a such a way that it should nullify the shielded magnetic field, so that it will differentiate the two spin states of a molecule. Then only it will absorb the energy. And all this is nothing but this is a positive shielding. So when the secondary fields produced by the circulating electrons opposes the applied field at a particular nucleus in the molecule, it means that effective field experienced by the nucleus is less than the. సో మనం ఏం చేస్తున్నాం, మనకి ఫర్ ఎగ్జాంపుల్ న్యూక్లియస్ ఉంది, అదేంటి హైలీ షీల్డెడ్. సో హైలీ షీల్డెడ్ కాబట్టి నేను బయట నుంచి ఇస్తున్నాను. సో బయట నుంచి ఇస్తే ఏం చేస్తుంది, హైలీ షీల్డెడ్ ఆపేస్తుంది, ఇవ్వనివ్వకుండా చేస్తుంది అనమాట. సో అప్పుడు నేను ఏం చేయాలి, ఎక్కువ ఎనర్జీ ప్రొడ్యూస్ చేయాలి. ఎక్కువ ఎనర్జీ బయట నుంచి ఇస్తే ఏమవుతుంది, ఈ షీల్డెడ్ అనేది క్రాస్ చేసుకొని న్యూక్లియస్ దగ్గరికి వెళ్తుంది. అందుకోసం చెప్పి యూ హ్యావ్ టు ప్రొవైడ్ లార్జ్ అమౌంట్ ఆఫ్ ఎనర్జీ. సో సెకండరీ ఫీల్డ్ అంటే ఏంటి, ద ఫీల్డ్ విచ్ ఇస్ ప్రొడ్యూస్డ్ బై ద సర్క్యులేటింగ్ ఎలక్ట్రాన్స్. So this is the negative shielding and positive shielding. So shielded are called as the higher electron density requires a strong field for resonance. Resonance is nothing but the absorption of radio frequency. So once again I'm repeating, resonance is nothing but whenever the molecule, every molecule is every nucleus is having its own or own precessional frequency. Precessional frequency is nothing but number of revolutions made by the spin in a second. And whenever the molecule is having the precessional frequency, and when the precessional frequency is equal to the frequency of the radio wave region of the EMR, then the molecule will absorb the radiation. That process is called as the resonance. And what is meant by de-shielded? So when a molecule is surrounded with the low electrons, that means low electron density, and it will generally absorb at a weaker field at a constant radio frequency. So all these terms are at a constant radio frequency. So in the picture itself, we have shown that. So in the case of 60 megahertz, we are applying the 60 megahertz radio frequency, but at a low magnetic field. So as it is very free, so it can easily absorb. But what will happen in this case? Is it is surrounded by the more functional groups, more electron withdrawing functional groups. So what will happen? Electron donating functional groups. So it may not absorb the same radiation. But so we are talking all this concept at a constant radio frequency. So by increasing the magnetic field only, you can make the molecule to absorb the radio frequency region. And so this is the chemical shift. So chemical shift is generally depends on all these following parameters: inductive effect, hybridization, anisotropic effect, and hydrogen bonding. So what is the inductive effect? So inductive effect is nothing but the electronegativity. So I already told, if the molecule, if the proton is surrounded with the electron donating group, so that the proton will be easily takes the electrons and it is more shielded. So you have to give the higher strong magnetic field from the outside. But if the proton is surrounded with the electron withdrawing groups, that is electron releasing groups. So electron releasing, what will happen? Electron withdrawing groups, they will take the electrons from the proton, so that electron is less shielded, and it will shows the NMR spectrum at a less magnetic field strength. So you can see this is the fluorine. So you know that fluorine is a more electronegative compound. What will happen? It will take the electrons from the proton. So what will happen? It will undergoes less shielded. That means de-shielded, and obviously it shows the higher chemical shift, higher chemical shift value. Once again, I am repeating, whenever the delta value is more, that means it is more de-shielded. And what will happen? This is a proton which is present This is the proton which is present besides the oxygen. So oxygen is also electronegative, but it is less bit electronegative. So what will happen? It is less shielded when compared with the fluorine. So, and the chemical shift value is decreasing. That means the chemical shift value is decreasing and it is at a high shield. Okay. So in the same case with the all these compounds. And